Okay, hello everyone. Today we're going to learn about the logic gates and how to make circuits with those logic gates and how those turn into Boolean expressions and how that's related with the truth tables that we have seen before. So we already know that we have a way to create logic in a computer by creating logic circuits, right? And those circuits are based on what we know as logic gates. And we also know that we have um, these six main or most important logic gates, which are AND, OR, NAND, NOR, XOR, NOT, right? And we also know that for each one of those, we have truth tables, which determine, given two inputs, for example, for an AND gate, Boolean inputs, because we know this means either true or false, right? What's going to be the result for an AND logic for those two inputs? So if we have false, false, then our logic says that false and false, it's false, right? And if something is false and the other is true, then saying the first and the second are true is false, right? And the same here, and the only case where an AND gate is going to be logically true is if both A and B are true, right? Okay, so that's just a little review of the logic in the AND gate. Now, XOR, it's another one that we saw, and it's one of the basic, and here it's basically, it should be one or the other, but not both, right? One or the other should be true, but not both. So if both are false, it's false. If one is true, then it's true. If one is true, it's true. But if both are true, it's false, right? Like, and we gave an example of like A is I'm alive, and B is I'm dead. So I can't be both alive and dead at the same time, right? So we use an XOR logic for that. All right, so now when we're talking about circuits, we need a way to to define those in terms of a diagram, right? To define those in terms of a diagram. So this is the diagram for the AND logic, and it's basically once it's kind of a rectangle that ends in a circle. I don't know how to call that. So that's just the way it is. This should be flat, and this should be curved, right? And this is the way you represent an AND logic. So A and B, and the result of this process here is going to be an A and B. The same thing, we have another symbol for OR gates. So if this is A and B, this is going to be, after this process, going to be A or B, right? And we have a NOT, which is very important in logic. It's very important to say no in logic. So if this is true, then the result of not true is going to be false, right? So this is the symbol for the NOT gate. And we also have one for XOR, which is this truth table. And we have the combination of NOT and AND. It's an AND. And it's just like you have the circle here, you're just going to put that circle at the end of the normal AND, right? So it's an AND with a NOT. Okay? And the same for the NOR. So it's going to be just an OR with a NOT here. Okay? So if that's clear, then we can create combinations of those logic gates in a, let's call it a logic circuit. So this is A, this is B. You know that this is not. So since I'm getting a B here, this is going to be not B. And this, since this is an AND, this is going to be A and, right, not B, which is what's getting here. All right, that's very simple, I hope. Now let's look at this one. Oh, it's complex, right? So here I'm just trying to use two different inputs and provide a more complex combination of logic gates or a more complex circuit. So let's look at this work. So this line is A, right? So I'm going here, I'm getting A, and this guy's coming from here. So this is a B and this is a not B, right? So here we have A and not B, right? So that's C. C is A and not B. Now in the same manner, this one is coming from, so look, let's look at this point here. This is coming from a not, and I'm going to look at what, not what? Not A. So this is not A, and this is B. So I can say that D is not A, right? And B. I think for some of you this is going to look familiar. And then we have an OR between those two, right? So what we're going to have in the end is the first one, which is the C, right? A and not B, and OR between that result and not A and B, which is the result of the D part, right? So this is D, this is C, and the result of this is E, right? Oops. So as you can see, just as long as you can follow the lines, then you're going to find what the result the of the circuit is. Now, one thing that you should be careful about is this, for example, this jump that I did here. This is going to just make sure that you don't, go this way and then you say, oh, that's B. No, no, no. You need the jump so you can see that this is coming from A, right? In different books and different texts and different people are going to make the diagram different, but you should notice the difference between, this, I mean, the crossings of the lines should be fairly evident to recognize. I mean, so I don't think that's going to be a problem. All right, so the last one. Now we don't have just two, but we have three. We have three different inputs. So that means that this expression is more complex now. And we're going to see how that looks in a truth table. So here I have A and I have not B, and this is an XOR. So D is, sorry. So D is A XOR not B. And that's in an AND. I'm sorry about the drawing, but you can see this is flat and this is curved. And there is a not here, so this is an AND. So all this is in AND with C, right? And that's all of that. It's A, right? So the expression at the end here, if someone asks you what this is, this is going to be just A XOR not B and C, right? Just like you have here. Okay. So now how's that going to look in a truth table? So how am I supposed to know how this works in a truth table? So let's check this out. I'm going to change color here so you don't get confused. So let's say that I have I'm going to calculate this 0, 0. So I have a 0 here, right? And I have a 0 here. So 0 goes here untouched, so I'm going to get a 0 here, and here B is going to get a not B, so if B is 0, not B is going to be a 1, right? Now, what happens when you have a 0 and a 1? 0 and 1 is 0, so you're going to have a 0 here. Okay, so it's a 1 here. All right? So let's analyze the other option. So I'm going to erase this and this. So what happens if this is B is 1? So not B is going to be 0, and 0 and 0 is 0. So this is 0 and this is 0, right? And we can just calculate that by looking at this truth table, right? Let's follow with the truth table. So 1 and 0, what's not B for 0? 1. What's not B for 1? 0. Now, if I have 1 and 1, so the result is 1, right? And you have 1 and 0, the result is 0. So this is going to be the result of this truth table, right? So with this, I can check and see how this circuit works. Okay, now let's do this one. This is more complex. I'm going to use the truth table. I'm not going to go through all the circuit here. No, I'm going to use the truth table. So not B is 1, 0, 1, 0, right? I'm just doing the NOT of this. Now C is the combination of not B and A, right? A and not B. So I make an AND between, wait a second, between this column and this column, right? So it's A and, so 0 and 1, 0 and 0, 1 and 1, 1 and 0, right? Now, not A, 1, 1, 0, 0. D is not A and B, right? Or B and not A, which is the same thing. So I can do 0 and 1, 0, 1 and 1, 1, 0 and 0, 0, 1 and 0, 0, right? Now E is an OR gate between these two, right? An OR between C and D. So 0 or 0, 0, 0 or 1, 1, 1 or 0, 1, 0 or 0, 0. So that means that if you notice, this is like an XOR. And that's part of the homework that you had, right? So, sorry about the noise on the background, but it's my beautiful Colombia. All right, so now what happens when we have three different inputs? So we have A, B, C, 0, 0, 0, right? Let's do this quickly because I see there's some kind of construction behind me. All right, let's do this quickly. So not B is 1. It's not this column, right? So 1, 1, 0, 0, 0, 0. Okay. Now D is A and, sorry, no, XOR. It's A XOR with not B, right? So it's A XOR not B. So 0 XOR 1 is 1. 0 XOR, wait, 0 XOR 1 is 1. 0 XOR 0 is 0, 0, 0, 0, 1, 1, right? Oof, that's so horrible. I just go back and make these zeros like zeros. So 0 and 1 is 1, 0 or 1 is 1, 0 or 0 is 0, 0 or 0 is 0, 1 or 1 is 0, 1 XOR 1 is 0, 1 XOR 0 is 1, 1 XOR 0 is 1, right? And E is this column with C in an NAND gate, right? So 0, 1, 0 NAND 1 is 1, 1 NAND 1 is 0, 0 NAND 0 is 1, 1 NAND 0 is 1, 0 NAND 0 is 1, 1 NAND 0 is 1, 1, 0. Okay, so that's the result for E. Alright guys, so now you know how to make truth table from a circuit and a Boolean expression from a circuit, right? Now the other way you could try to understand this is to create an expression circuit out of an expression, right? But that's also very simple. So you can do, for example, let's say I have A XOR B and C and D, okay, and C. So you have A, B, C. So A XOR B, right? And the result of that, NAND C. So I have a NAND, and there you go. So making a circuit out of an expression is even easier. Alright guys, so that's it for today. I'll see you next time.